കഴിഞ്ഞ വീഡിയോയിൽ നമ്മൾ ചെയ്തതിൻ്റെ ബാക്കിയാണിത്. അവിടെ നമ്മൾ ചെയ്ത് നിർത്തിയത് ലിമിറ്റ് എച്ച് എൻ ടെൻസ് ടു 0 ജി ഓഫ് എഫ് ജി കോമ്പോസിഷൻ എഫ് ഓഫ് ഇസഡ് നോട്ട് പ്ലസ് എച്ച് എൻ മൈനസ് ജി കോമ്പോസിഷൻ എഫ് ഓഫ് ഇസഡ് നോട്ട് divided by hn. Then we take case 1. Case 1 is what? F of z naught plus hn not equal to f of z naught. So you just add and multiply and divide with f of z naught plus hn minus f of z naught, and you just transform limit hn tends to 0 g composition f of z naught plus hn minus g composition f of z naught divided by hn into g composition f of z naught plus hn minus g composition f of z naught divided by f of z naught plus hn minus f of z naught into f of z naught plus hn minus f of z naught divided by hn. Then you just apply limit on both sides, limit hn tends to 0, and also apply the definition of composition function. How we can define g composition f of x is equal to g of f of x. So you just apply the definition of composition here also, and also you just recollect limit h tends to 0 f of a plus h minus f of a divided by a plus h minus a. If this limit exists, this must be equal to the derivative of f at the point A. You just compare these terms with this. Then how can you write limit h tends to 0 g of f of z naught plus hn minus g of f of z naught divided by f of z naught plus hn minus f of z naught. What is this? What is this? By using this definition, you can write this term limit h tends to 0, this equal to, what is this? G dash of f of z. G dash of f of z naught എന്ന് വരും. G dash of f of z naught into G dash of f of z naught into, what is this? Limit hn tends to 0 f of z naught plus hn minus f of z naught divided by hn. This is equal to f dash of z naught. So g dash of f of z naught into f dash of z naught. So what it implies? The limit exists and the limit is equal to g dash of f of z naught into f dash of z naught. That means g composition f is differentiable at the point z naught, where z naught is a point in G, and G composition f dash of z naught is equal to G dash of f of z naught into f dash of z naught. So for an arbitrary point z naught in G, and the case 1, what is case 1? F of z naught plus hn not equal to f of z naught plus hn not equal to f of z naught. This is case 1. So for case 1, f of z naught plus hn not equal to f of z naught, and for f of z naught plus hn not equal to f of z naught, and z naught is an arbitrary point from G. So for this z naught, we verified that G composition f is analytic. That means since z naught is arbitrary, we can say that G composition f is analytic on G, and G composition f dash of z, G composition f dash of z is equal to G dash of f of z into f dash of z. So this is case 1. What about case 2? Case 1 is f of z naught plus hn not equal to f of z naught. So what about case 2? Case 2 is equal to f of z naught plus hn. Case 2 is equal to f of z naught plus hn equal to f of z naught. for infinitely many n. F of z naught plus hn equal to f of z naught for infinitely many n. So in this case also we need to show that f of G composition f is differentiable at the point z naught, and G composition differentiable, then derivative exists at z naught. So how we can evaluate the derivative of G composition f at the point z naught? That is G composition f whole dash of z naught is equal to G of f of z naught, G dash of f of z naught into f dash of z naught. So in this case also you need to show both the cases. That means decomposition f is analytic and the derivative is equal to this. So you repeat the same procedure. You just take z naught belongs to G, z naught belongs to the open set G, then you have to show that G composition f is differentiable at the point z naught, and G composition f dash of z naught is equal to G dash of f of z naught into f dash of z naught. So here you keep in mind that f of z naught plus hn equal to f of z naught. So in this case you need to split your hn, write the sequence hn as the union of two sequences. You just write to sequence hn. Here we take the symbol this. In Conway, the symbol used for denoting a sequence is like this, curly bracket. So in this case, first you have to write your sequence hn as the union of two sequences. Sequence kn and sequence ln. So you first write your sequence hn as the union of two sequences, sequence kn and sequence ln. So now your sequence hn is the union of two sequences, sequence kn and sequence ln. Then so also assume that f of z naught plus kn not equal to f of z naught and f of z naught plus what is the another ln, f of z naught plus ln equal to f of z naught for every n. Also assume f of z naught plus kn not equal to f of z naught for every n, and f of z naught plus ln equal to f of z naught for every n. Then what will happen? What about this term limit? Limit ln tends to 0, f of z naught plus ln minus f of z naught divided by ln. What is this? Limit ln tends to 0, f of z naught plus ln minus f of z naught divided by ln. In your statement, you have given that f is analytic on G. So f is analytic on G means at each point of G, f is analytic. So here you take here your z naught is from G. So f is also analytic at z naught. So what is this? Limit ln tends to 0, f of z naught plus ln minus f of z naught divided by ln. This is equal to actually this is equal to this limit exists, and this must be equal to f dash of z naught. F dash of z naught. But here your assumption is f of z naught plus ln equal to f of z naught. So what will happen to this limit? F of z naught plus ln minus f of z naught equal to 0. You are assuming like this, f of z naught plus ln is equal to f of z naught for every n. So what about this limit? Limit ln tends to 0, f of z naught plus ln minus f of z naught divided by ln. Actually, this is derivative of f at the point z naught. This derivative must exist. Since these two terms are equal, what will happen? This derivative is equal to 0. So f dash of z naught is equal to 0. That means limit ln tends to 0. F of z naught plus ln minus f of z naught divided by ln equal to 0. F dash of z naught, which is equal to 0. Now you are suppose you are considering limit ln tends to 0 G composition. You need to find the derivative of G composition f. G composition f of z naught plus ln minus G composition f of z naught divided by what is the denominator here? Limit ln tends to 0, G composition f of z naught plus ln minus the limit G composition f of z naught divided by ln. What is this? G of f of z naught plus ln minus G of f of z naught divided by ln. Limit ln tends to 0, G of f of z naught plus ln minus G of f of z naught divided by ln. So what is this? G of f of z naught plus ln minus G of f of z naught divided by ln. What is that limit? Limit ln tends to 0. G of f of z naught plus ln minus G of f of z naught divided by ln. That limit must be equal to 0. How you got this limit is equal to 0? G composition f of z naught plus ln minus G composition f of z naught divided by ln is equal to 0. We have f of z naught plus ln minus f of z naught plus ln minus f of z naught equal to 0. Here you are assuming that f of z naught plus ln is equal to f of z naught for every n. So f of z naught plus ln minus f of z naught equal to 0. So this limit, what will happen to this limit? This limit is equal to 0. This limit is equal to 0. Now you have one more sequence remaining. What is the remaining sequence here? Throughout your proof, you just take this sequence ln. But your Hn is the union of two sequences, sequence ln and sequence kn. So suppose you just take limit kn tends to 0, G composition f of z naught, what is this? Minus G composition f of, this is f of z naught plus kn minus G composition f of z naught divided by kn. This is kn. What is this? G composition f of z naught plus kn minus G composition f of z naught divided by kn. By the first part of the proof, here f of z naught plus kn not equal to f of z naught. So by using the first part of the theorem, you can say that this must be equal to what? This must be equal to G dash of f of z naught into f dash of z naught. By the first part of the proof, you can say that this must be equal to G dash of f of z naught into f dash of z naught. What is your f dash of z naught here? F dash of z naught. F dash of z naught is equal to, you already obtained that f dash of z naught equal to 0. So what is this? This equal to 0. This is equal to 0. So you obtain that a limit kn tends to 0, G composition f of z naught plus kn minus G composition f of z naught divided by kn is equal to 0. So what will have? Your aim is to show that limit Hn tends to 0. Now your Hn is the union of these two sequence kn and sequence ln. Limit Hn tends to 0, G composition f of z naught plus Hn minus G composition f of z naught plus Hn minus G composition f of z naught divided by Hn. This is what actually this is equal to, by using this result, by using this part, you can say that this is equal to G dash of f of z naught into f dash of z naught. Or otherwise you can say that this limit must be equal to 0, since Hn is the union of two sequences, sequence kn and sequence ln, and limit ln tends to 0, G composition f of z naught plus ln minus G composition f of z naught equal to 0. You can say that this must be equal to 0. This must be equal to 0. This limit must be equal to 0. So what this 0, this 0 must be equal to what? G dash of f of z naught into f dash of z naught by using this part. So limit Hn tends to 0, G composition f of z naught plus Hn minus G composition f of z naught divided by Hn is equal to G dash of f of z naught into f dash of z naught. Since z naught is an arbitrary point from G, you can say that G composition f of G composition f dash of z, G composition f dash of z is equal to G dash of f of z into f dash of z, since z naught belongs to G is arbitrary. Okay.